regenerative buildings, given by Arup. At the end of this lunch lecture, you will receive my future points. We will stand with the scanners upstairs. So now I will give the word to Christa.
Thank you. I have a bit of a cold, so I hope I'm good to hear. So I work at Arup, Christa de Vaan. I used to study here. I had a master of building physics, and then I went up to work, and I wanted to design holistic, energy-efficient buildings. So I went more towards mechanical engineering. And now I'm in the sustainability team in Arup. And what I usually do is that I work on larger, innovative buildings. And I'm project manager, project design manager for these buildings from Arup. So Arup, what do we do? So we're an engineering firm. And basically we do anything that you can engineer and calculate around the built environment. So it's tunnel design, lighting design, acoustic design, energy design, nature design, structural engineering, like everything together. And this is Ove Arup, and he was the founder of our company, and he really believed in total architecture. So basically bringing all these disciplines and architecture and landscape design together and creating a holistic and a better design by really integrating all of these things. And he could really use that thinking in one of the first buildings he worked on, and this is one. So he started the company just after the war. And then he won this competition, and he basically, that I'm able to show this picture is actually quite a coincidence, or quite, it wasn't that obvious, because this building was considered, or this design was considered to be unbuildable. So it took quite some effort and really that total architecture design thinking to realize it. And the first things that were needed to do, that they needed to do, was simplify basically this really complicated design. So it's all that you see is based on spheres. So they found this pattern and were able to make a less complicated design that was based on these spheres. So after the Sydney Opera House, Arup expanded. We're now a global firm with 87 offices. One small dot over there, that's the Amsterdam office where I'm located. I've worked also in other offices, but I'm now currently in the Amsterdam office. I'm briefly going to show you a couple of projects, and then afterwards I'm going to show you a little bit more into depth what we do, a couple of our projects more in detail. So this is Zuidasdok in Amsterdam. This is like the heart of, in Amsterdam, all the districts coming together. Oh, wait, it wants to move forward. So this is highly complicated because it combines tunnels, a major highway, major train infrastructure, metro infrastructure. So this is something that brings total architecture together in this sense. This is the Binnenhof, our Dutch parliament. It's always fascinating to talk about foreigners about this project because it's so strange and unique that we have this building really in the middle of the center, which is really approachable. And we wanna obviously keep this heritage. It's a beautiful buildings. But do it in something that is future-proof, so energy efficient, safe, and also comfortable. The Supreme Court in Den Haag, also safety, comfort, really luxurious, and also making a sort of statement around judgments. This is the MX3D bridge. This is a 3D printed steel bridge, which we worked on, and this is really about designing a building that is designing a more efficient structure and using this material in a different way. So at the People Pavilion here in Eindhoven, it was 100% circular building. It was completely borrowed, and everything was disassemblable, and everything was taken back to the original owners when it was demolished after a short while, because it was a temporary building. And Lokhal in Tilburg, which is a library and a lot of other functions. I don't know why it's going further. A library and other functions are located into this building. And what was here, really the trick was, this is an old heritage building, and we wanted to create it to be comfortable. So those two sort of are not well mixed. So what we did is we created really a local comfort, really around the people. So not climatizing the whole building, but actually around the people. Yeah. So then on another foot. So you probably have seen all of these graphs with like these depressive exponential growth. And this is exponential growth showing in the blue, that's the world population, which will grow on a little while further. And then what you see as well is the CO2 exponential growth of that. And you see also the dotted line, which is showing what is the prediction, or what is our aim basically, to go to net zero emissions. So this is also, unfortunately, triggering also other exponential growth like material extraction, fertilizer, freshwater use, etc. But I want to give you a positive message as well. So I want to show you this graph, and this is a solar energy market growth graph, and what you see in black is what actually happened. So that was the solar energy market growing, and what you see in yellow were every year the predictions that were made. So for example, in 2010, I'm not sure if you see my cursor as well. Can I go there? No, in 2010, you have to believe me, you see that yellow line going horizontal. So the experts thought like, okay, we now had a lot of growth in the solar energy market. It will flatten out. And they thought that the next year, the next year, the next year. So they always underestimated the growth. And these are not just people thinking about this, these are experts thinking about this. And still, it was hard to believe. So this is something I find fascinating, that our brains just can't grasp the impact of exponential growth. And that is what we need. We need strategies to help us fight the negative exponential growth and go towards a positive exponential growth. Also with solar panels, we need to go to circular solar panels, and they need to grow exponentially as well. So we need to find these strategies that can help us solve these problems. And what we can do is we can help accelerate growth as well. So in every project that we do, we try to figure out what it is that we can push, what it is that we can grow exponentially. And usually what happens, if you see this graph, and it's also the image on the right, it shows you like in the beginning when you start something and you have a new idea, it's always hard work. Nobody believes you, it's difficult to get it to the next step. And then there is this tipping point, and after that, things will accelerate. And it's about accelerating that tipping point and finding the strategies that help do that. And that brings me to this project. So this is a project we've done, and it's called Hout. It's in Amsterdam. Again, moving forward. And this building is, when we went into the competition, one of the interesting things about this competition is, and I think one of the really great things our governments do, is that it was not only on price and on architecture, but sustainability was an important ingredient for winning this competition. So we sat together with Team V, who was the architect, and the investor, the developer, and we thought about what is going to be the thing we want to aim for in this building, and we decided, let's build it in timber. And back then, everybody was saying it's not possible, crazy idea, and we had to bring in experts from the different offices from around the world to see how we could make this work. And in the end, the building is made out of partly timber and concrete, and that is sort of a little bit of a compromise, and that has two reasons. And one of that is efficiency. If you build it only out of timber, you get sometimes massive columns, and it's not going to be realistic anymore, depending on the shape of your building. And the other thing was that safety for everything. And I think the big risk that we saw when we started this building was that there was no regulation. There was regulation for high-rise, but it was always with concrete in the back of the mind. And with timber, as you can imagine, there's a lot more happening, and we don't want this to become the next Grenfell Tower being on fire. So safety was the first thing, also because that would be really damaging for the whole timber market if we would make a mistake with this first building. Yeah, fire is a thing. So all these things that concrete usually solves in a building is now something that you really need to think about. So for example, the fire, acoustics, structural integrity, and also building service integrated into the building. That's really important. So what happened is that, so after this project, there was no discussion if it was feasible anymore. Oh. There was no discussion anymore if this was feasible. We now have a building standing there, so it is feasible. So that really triggered the market. And at the moment, we see that next to concrete and steel, timber is a really logical, obvious other option that we take into account. And often it's now winning from these others. Then the Echo building, that's in Delft for some minor, insignificant university. And this was about, let's not look at only designing this building, but also and adding square meters, but really thinking about from the people, starting from the people and building the building around them. So aspects like light, air, influence, choice, and balance, I'll walk you through how we looked at the design. So first of all, light. No artificial light can replace daylight. So daylight is really crucial for our mental health. It's really, really important. So what we did, as you can see, it's a really transparent building, and that had the reason because we wanted to have a lot of light, but also because the university wanted to showcase really what's going on in the inside of the building and really making a transparent building. So it's light from the it's glass from the outside and also glass from the roof. And also from an energy point of view, this made sense. We had quite low energy heating and cooling system, which I'll tell in a second. But lighting was still something that was quite a significant part of our energy use. So that's what we wanted to solve. And also, like you see on the left with the graph, and sorry, it's also partly in Dutch, but what we wanted to really integrate and really have that total architecture coming out. So things that we do for health and comfort also support architecture and space use and sustainability and circularity. And we looked at that for all the measures that we took, like how do they create a synergy between all these three aspects. And then the roof is really like expanded so that it can cover as much as possible the PV and producing an energy positive building. What this building also has is we turn things upside down when it comes to air supply. So usually you would have air supply from the top, and what we did is air supply from the bottom. So I think before I needed to explain like how important fresh air was. I think after COVID, everybody knows how important fresh air is. And this is really an important strategy when it comes to that. And I think the images below really show what's happening. So if you have a room, a space filled with dirty air, and you go and add air from the top, you're just mixing and making it all a little bit less dirty. If you add air from below, then what happens is we're all actually little chimneys. We're all warmer, we're 37 degrees, we're warmer than the air around us. So what happens is that the air around us warms up and we become, the air is lighter, so the air wants to go up. So we become these little chimneys. And if you then supply air from the bottom, then what happens is that that seeks your breathing space. So actually the space around you becomes really clean air and the dirty air is removed to the ceiling. The other thing that is with this system is that it doesn't have ducts. So it's just blown into the raised floor. And it doesn't have ducts, so that's basically like if you blow on a plastic bag and you make a hole in that plastic bag, then it will come, the same amount of air will come out wherever you put that hole. And that's the same thing with this system, that we just put a grill in the floor and where we put the grill, the air will come out. So it's a really plug and play and circular system, also because we use like the same grill in every room. And like usually you need to really select a grill for each room and make it specific. So this is for a circular market in which we want to reuse this system for a completely other building in the next years, or when the building is demolished at some point. This is possible with this kind of system. So this is that system thinking, not only about your own building design, but also in the future. And what we did was also look at comfort in a different way. So there's not just one type of comfort. People perceive comfort differently depending on what kind of activities you're doing, also your personal preferences, of course. But what we could mostly work with is that different types of activities around the building. So it's more healthy also to have different types of comfort around the building. So we use that into our advantage. And we really, because we had such a plug-and-play system, we really looked at where we wanted to create what level of comfort. And that also saves energy, because you're not making this like one type of comfort everywhere, but you allow for some bigger bandwidths in some areas. Then where this all comes together is in Mediavaart in Amsterdam. This is the largest timber office building in Europe. And it's just finished, so our king opened the building, and I'm only going to briefly talk about this. There's a lot to tell, but I also have other projects to show. But I think I also visited it now that it's completely finished, and it's amazing how this timber building, how you really approach that differently, and that's also what the people who work there, what they basically say is that this building really feels differently. It's the timber. It's really a different kind of construction material, but it also really makes you feel different. Then we have Energy Academy in Europe, and now I'm going to let somebody else talk, if that will work.
In our new Energy Academy Europe building, we are working together towards the transition to a sustainable energy future. We provide education, conduct research, and foster innovation in the field of energy. This is also reflected in our building. Welcome to the most sustainable educational building in the Netherlands. The guiding principle is to create a natural climate, natural airflows, solar energy, using the earth for heating and cooling, rainwater, all energy from natural elements and with minimum technology. Aligned towards the sun, this remarkable building is ideally positioned. A compact shape with a small surface area to minimize heat loss. A large atrium has been built between the two parts of the building to allow light to enter everywhere. A winter garden, also made of glass, has been added to contribute to natural ventilation. Through smart design, we have created a building with zero emission. More than that, a building that produces more energy than it consumes. It can withstand earthquakes. It uses almost no energy, and it has the highest possible BREEAM score. The building slopes down on the sun side to best capture solar energy and maximize light. The solar panels could cover the entire roof, But by placing the 2,000 panels in a special triangular configuration, we have been able to fit more panels on the roof, capturing 37% more solar energy. This also leaves gaps for sunlight to get through, which reduces the need for artificial light. When needed, energy-efficient LED lighting switches on automatically. A natural flow of outside air runs through the entire building. Fresh air comes in through the winter garden and enters a 200-meter-long labyrinth. This sits below ground so that the air steadily reaches the current ground temperature, moving at a rate of less than a meter per second. This provides cooling in summer and heating in winter. All in all, nature gives us 4 degrees for free. This constant airflow is drawn into the building thanks to the solar chimney at the top, which is the warmest point and creates a draft. This natural ventilation saves about 20% in ventilation energy. The fresh air passes from the labyrinth to the offices, the atrium, and then via the solar chimney to the outside. On summer nights, there is additional cooling through a natural process that requires no energy. Cool night air flows through the winter garden, via the atrium, and through the entire building. The next morning, people can start their working day in a cool environment.
Yeah, so a building that brings a lot of passive elements together and annoying. So another building that sort of does that and that we really looked into, like how can you work with all the elements together and come up with the best shape of a building from the start. So how you used to do that in the old days is you create these different options and you start to analyze these options for every aspect. But usually you will figure out at some point in the design, like, shit, it should have been just a little bit of a different shape. This doesn't work perfectly, and if we only have known from the start. So as designers, so we're together working on this in a design team, and as designers we make like thousands of decisions during the design process, and for all these different things. So it can be around like getting enough sunlighting in, reducing the energy, it's about ground settlements, it's about wind dynamics on a building. So we want to take everything that we can get and every data that we have to use that as fast as possible in the design phase, so as early as possible in the design phase. And this is what we did. So this is already a sort of fine-tuning. You see that the algorithm is fine-tuning the design shape of this building, this elements building. It's, again, a residential building, and it's really looking for the most optimal design shape. And the things that we have analyzed in this building are those priorities that we found, the key performance indicators. So one of them was daylight, it was direct sunlight and having passive energy in the building. It was about the wind dynamics around the building so that we would reduce the wind also on the neighbors, and also having a green building. It's about the planet, so also energy efficient building and using the least amount of materials. So by doing that, by parametrically designing buildings, we can create like 10,000 of options and analyze them all and get the information and do really data-informed decision-making on our designs. So this brings the whole idea of total architecture to another level, and I think Arup, he isn't alive anymore, but he couldn't have imagined, I think, that we would do these things nowadays. So this is where we are at the moment with this building under construction. So hopefully next year it will be finished. And then I want to bring you to this building. That's Habitat Royal. It's in Amsterdam, and as you can imagine, this building was about nature-inclusive design. So we wanted to see how we could go the next step with nature inclusive design. So what we saw, like, nature is really good at adjusting habitats and really finding its way. And in the last years, of course, the built environments had taken away a lot of habitat. The agriculture has taken away a lot of habitat. And what is happening at the moment is that when we build buildings, we often also do that not with nature in mind. And also, for example, if you insulate your building at some point, then it's about compensating nature. So basically, if you remove an habitat of a bat, then you need to replace that by a bat box for that bat. But we wanted to go beyond compensation because we want to work towards nature positive design. And to get there, we need to think differently. So together with the design team, again, this was a competition. We were thinking about, like, how can we do this? How can we get nature inclusive design to another level? Not just build a green roof, but do something different. So this building is located close to the Beatrix Park. So we wanted to do more park. We wanted to do more ecology, and we wanted to do more soil. Because soil is like it looks like simple dirt, but it's actually full of life. And if that's full of life, it's also on top of it, it will be full of life. So in one of our first rounds of thinking, we started to think about creating micro-habitats, because nature doesn't just need like a certain plant or a nest box. It's a combination of elements that need to get together to make it work. So, and we wanted, like I've shown for Echo, that we wanted to design around the human being. Here we wanted to design around those habitats, around these species. So what this sort of led to is that for every type of facade, we have a different type of habitat. So for example, on the north facade, this is a really good facade to have nest boxes in. So we created the right vegetation for the right type of nest boxes. Here we have a shorter overhang to allow more sunlight into the building. On the south, we have deeper overhangs, and we focus a lot on those plants and species that require a lot of sunlight. So it's more, we have bee nest boxes and butterfly nest boxes, and more of a flower garden kind of habitat. Oh. And then on the east and west, there's always a problem related to energy, because there the sun comes in perpendicular, and it's always difficult to shade that sun. So what we did is we placed there plants with leaves, which would fall off in winter. So in winter we would have passive sunlight coming through, and in summer it would be shaded by the leaves. And here there's also, it's focused, the type of plants that there are focused around the type of birds, etc. that are there. So it's feeding them, but also providing shelter. So usually when a bird comes out of a nest box, it wants to sort of stick around, and within 5 meters wants to find bushes. So in this case, we were able to do that. And basically, by building these overhangs around the building, we were able to connect the ground nature with the roof nature in a better way. We built in these layers in between, so actually insects can reach the roof at a higher level. Also here we use data to inform us on where which microhabitat could be placed and how to work with that. And together with the landscape design, we started filling in all the plants and the types that we needed on each orientation. With the ecologist, we started designing a residence for other residents. So this is really bat boxes, bird boxes integrated in the facade. We started exploring the different options, and we wanted to integrate as much as possible opportunities to also learn from this building what types and what shapes were the preference. So here you see that we started optimizing the depth of the overhangs and how that would influence not only nature, but also passive heating, passive cooling, and daylight into the building. So this is a rendering of the design. We're now a detailed design. So here you can see in the overhangs, you see those holes in the top, and that are the nest boxes that are located there. So here you see how that all brings together. Yeah, and here a couple of other images showing how those microhabitats work. So when you think about nature, you might think that nature is better off without us. And I really like this story about this native person from America and her family. And they were telling this story about key species. So key species, if you're an ecologist, you know key species are very important and really relevant animals. Like, for example, the bee, the wolf, and the beaver. If they fall away, then the whole habitat falls away. And what they were saying, that humans used to be a key species. So they would design their environment because they were very much reliant on their environment for food and shelter. So they really interacted with the environment so that the environment could flourish. So that is sort of the thinking that we have, like, hey, can we start to become more like a key species, a keystone species for nature, and start to design nature so that it can flourish? Yeah, so how that also works on and how that can start to accelerate implementation of, for example, nature in this case. Wild West End is a great example of that. So this is a location in London, and there was 2 nature areas were there, and they wanted to connect those 2 nature areas because that would build a stronger ecology. So what they did is they started talking to all the building owners that were living around that route between those natural areas, and started to convince them, like, hey, can we create more green around your building? And that was a success. So all these building owners wanted to contribute. And also when you see your neighbor turning their building all into green, it starts to spark also some ideas for the other building owners. And it was so popular that at some point also the building owners that were not on the route, but actually perpendicular to the route, were also interested in joining into this movement. So I want to leave you with this thought that, exponential growth, I think we need to believe in it. We need to understand that our brains are just not able to capture what is possible in the next coming years. When I started as a building engineer, then sustainability was still a dirty word. Nowadays, sustainability is a word that really, if you don't mention it, you're out. So I think, and also talking to you, you're the next generation. Please explore and push this further, and believe things that your brain isn't able to imagine at the moment. I want to leave you with that. If you want to know more about Arup, interested at some point to work with us, then let me know, drop me an email. All right, thank you.
Thank you very much for giving this very interesting presentation, and thank you all for being here. As a little thank you from Cheops, I have our magazine and a bottle of wine for you. For all of you here, thank you for being here again. We have another lunch lecture coming up next week on Tuesday. To get your My Future Points, you can scan your student card upstairs. Thank you.